Okay, we're ready to do some examples calculating probabilities with the normal distribution. So let's start with an example, the probability that z is less than -1. So recall z is the standard normal distribution. So standard normal, right, z has a mean of 0, standard deviation of 1. That's what we mean when we say z, standard normal. So we want to start with standard normal because, as we said, it's the simplest version of the normal distribution. So with our picture, I'm going to center it on 0 because we know that z has a mean of 0. And we want to find the probability that z is less than -1. So what we want to do is find this area to the left of -1. So we want to find this area right here. So one of the ways we're going to calculate probabilities with the normal distribution is to use our tables. So this is posted in Schoology. We have our normal tables. And what it's doing, so this first table is it's showing us the probability of z less than some negative value right here. So to make this clear, let's just go ahead and use our example. So we want the probability z is less than -1. So our z value right here is -1. And we want to look up in this table this area here that's shaded in this picture. So this table will give us the area of the shaded region. So I want to look up the value -1. And I guess perhaps more specifically, we want to look up the value -1.00. So to do this, our z values in this table correspond to the rows and the columns in this table. So I've got my z value, and I want to go to -1.00. So what I do is I scroll down to -1.0, so -1.0, and then I want 1.00, so I'm going to use this first column. So I see that my area is 0.1587. So that means that the shaded region in this plot up here is 0.1587. So let me go ahead and write that. That means this is 0.1587. So, and that's our probability. So the probability z is less than -1 is 0.1587. So let's do another, but let's now do probability z is less than +1. So I'm going to snag another one of these. Okay, so it's still centered on 0, but now we want to look up the area to the left of +1s. I'm going to write 1 here. So now in our plot, we want to look up this area here. So we now are going to use our other table. So this first table just gave us probabilities to the left of 0. But now we want to use the second table, which gives us probabilities to the right of 0. So we can see over here, it gives us all of this, which is what we're interested in now. So now this z value is represented by positive values of z. So in this example, we want the area to the left of 1. Specifically, again, it's 1.00. So using this table, we still have our z value here. We go down to 1.0, 1.0. We want 1.00. So I see my area is 0.8413. So my area is 0.8413. Okay, and now let's say we want the probability that z is between -1 and +1. Okay, so we want -1 here and +1 here. And now I want the area in between these two values. So we want this right here. And we know it's still centered on 0. Okay, well, here neither of our tables give us the ability to look that probability up. So we're actually going to just go ahead and utilize the fact that we know that from here over, redo that, from here to here, this is 0.8413, right? We knew that from this example. And we know that this area is 0.1587 from our first example, so 0.1587. So I only want the area between -1 and 1. So to do that, I can just simply subtract these numbers. So I'll rewrite this as probability of z less than 1 minus the probability of z less than -1. So this will be 0.8413 minus 0.1587. Actually, I didn't calculate this yet. Let me grab my calculator. We can see that this comes out to 0.6826. Okay, so let's do another example. Now let's do the same thing, except let's do this with 2's. So let's say we want z less than -2. So let's draw this. So still centered on 0, but now instead of -1, we're going to look up -2. So we want the area to the left of 2, which is going to be here. So let's go to our table. So we're going to use this first table because we now have a negative value, -2. So now this is going to be -2. So I go down, okay, but we're not looking up -1. We want -2. We can see -2 here, and we get 0.0228. 0.0228. Okay, so now let's do probability z is less than +2. So 0, I'm going to put a +2 here, and we want the area all the way, all of this. So this is a positive value of 2, so we're going to go to our second table. So instead of 1.0, it is now 2.00. So instead of 1, we're now looking up 2. So 2.0 gives us 0.9772. So we get 0.9772. And then, again, let's do probability between -2 and 2. So let's draw this. We just want between -2 and +2. So I want this area. Now I'm going to use the same logic like we did before. So I know that from here over is 0.9772. And I know that this area is only, what was it, 0.0228. So that means I can rewrite this as the probability that z is less than 2 minus the probability z is less than -2, which is equal to 0.9772 minus 0.0228. 0.0228. We calculate that. We get 0.9544. Okay, now let's go ahead and do this with threes. And I recommend pausing the video and working through these yourself. So probability that z is less than -3, probability that z is less than +3, and the probability that z is between -3 and 3. So go ahead and pause the video and give this a shot. Okay. So let's go ahead and do this. So I want the probability that z is less than -3. So we're going to start with our first table because this is a negative value. So before we had -2, but now it is -3. So I scroll down to -3. Okay, so -3.00 is right here, and we get the area of 0.00135. So very small, 0.00135. Okay, now we want the probability that z is less than +3. So +3. So we want this whole area. So I'm going to use our second table. So +3. So 3.00, it's a little big. 3.00.99865. So if I want the area between the two, we know that we'll just subtract these, so 0.99865 minus 0.00135, and we get 0.9973.